Okay, welcome to the December TriEmbed meeting. We've got some new people, I think, tonight. If you don't mind going around introducing yourself, letting us know how you found the group.
Okay, I'll talk. This is Chuck. I've been here many times before, but haven't been here lately. And so, hello, everybody.
Okay, there was a
I'm Pete Hollenbeck. I was at some of your meetings when you were still at NC State and fell out with the pandemic, and am back.
glad to have you with us. Oh, there's Nick. There was a MI space K or L or something that was on, but it's now gone.
That was Nick. He's motioning that was him, but
Okay.
he's now Nick, and he's not talking too well.
All right.
But he still can smile.
All right. Any announcements? Things going on other than the concert coming up in a week and a half? For January, we're going to try to do an in-person get-together, probably at a restaurant of some sort that has a little meeting room. But the details are to be worked out. So keep an eye out in the mailing list and we'll. Okay. Let's see. If I share my screen. All right. Can people see that?
Yes.
Good.
Yep.
So I don't know.
Yes, can see it fine.
Thank you. I don't know about you, but last night the power went out at my house. And I've got some stuff on my at home that sends a notification to my cell phone when the power goes out and when it comes back on, so I know the times.
How far were you from that tornado? Did that affect your power much?
I don't know the answer. My understanding is the tornado was up toward Franklin County. I'm at the beach, so I don't know what's going on back in LA.
Yeah. In Wake County, the Garner area heading up northeast is how the tornado went.
Yeah. So that's not near where I live, but a tree got blown over onto some power lines or something. And so that's, a little over an hour off of power. And one of my computers did not come back on. One of the ones that I used to get back to my home network, but I did find a workaround. I haven't checked it because I'm not there, but I assume that the UPS ran out of juice and turned itself off. So I have a number of these APC UPS things with a computer or a router or a television or whatever plugged into it. And they were great for a minute or two outages. If it goes on too long, they shut off. And then I have to press the power button to get them to come back on. So as I mentioned, I have a script that runs on a Raspberry Pi. So I got a little Pi hung off of one of these UPSs. And so it runs for quite a while on that battery. And so when the power goes out, I get a notification sent to my phone, and when the power comes back, um, I get a notification, provided the UPS didn't shut all the way down. So I can tell when it happens. Um, but it's really tough to press the button when I'm a couple hundred miles away. So the problem of the month is how could I make this more robust? Are there different kinds of UPSs that would allow remote power cycling, or do I need to make some robots that push the buttons?
I wouldn't think you'd need a robot because most of those buttons are momentary. So just providing the equivalent of another button parallel to it, like a transistor circuit or something like that, MOSFET or what have you.
Okay, so as long as I had most of my home automation stuff uses Wi-Fi. So as long as the Wi-Fi was on, I could send a message to the.
And how are you going to power this robot with no power?
Well, I'm assuming the power comes back on. Clearly, if there's no power, I can't recover till the power comes back on. And if that goes on, then I've got other problems, I guess.
Well, you could just have a momentary solenoid that went clink when the power comes on.
Well, that would turn the UPS off, right? Maybe if it hadn't gone off.
Well, it could go clink clink.
I forget whether you have to press and hold it. Um, I know to turn it off while it's running, you can't just do a little jab. It ignores that. But I have not experimented much with turning it on. That's worth definitely a low tech solution there. That might
Does it
work.
does it not have a setting to power back on when power comes?
I don't know that it does.
I mean, I guess maybe you want to keep from. Maybe you don't want it to come back on immediately if sometimes there's spikes and stuff if it's on and off.
I mean, if yeah, um,
A lot of UPSs have a wired remote jack that you could tie into.
I mean, so um, the way I'm detecting it, there is a USB cord that goes between the power supply and the Raspberry Pi, and a daemon that runs, and it detects various events that happen on the power supply. So that's how I know when it goes off of battery and when it comes back online. Um, the problem would be if it never comes back online and the battery drains and then the thing shuts down. I guess
Usually they shut
it
down
probably
far
seems-
earlier than their internal circuit. Their internal circuit's able usually to operate for a lot longer than what the inverter is providing power for.
Yeah, there probably is a setting for initial power on. and I'm able to remotely diagnose which things came back on and which things didn't by trying to ping various IP addresses. So I know
Did
which
you know how
button
long
I'm
it
to
was
push
off?
at the moment.
Did you know how long it was off? Like, was it long enough that all of them would have shut down?
It was off for an hour and 10 minutes.
So maybe in
Um,
the middle. Like, do you ever have it off long enough that they're all shut down? Or I was just wondering if some of them had different behavior and they do come back on.
I think the one that's powering the Raspberry, I don't think that one has ever run down enough that it has shut down. The ones that have a computer on them will last half an hour, 45 minutes. Um, I guess two of them lasted the 70-minute power failure because they came back on, or they didn't shut down.
It sounds like there's an assumption here that you've got a UPS that's going to have enough power to keep the Pi running, your Wi-Fi running, your internet connection running. And since it doesn't have much load, you hope you'll get an hour or so.
Right.
And what I do is I'd also, in addition to your button pushing, take two AC optocoupler type things, and you can know if you have line voltage, and you can know if you have anything coming out of your UPS. And I would imagine with those three abilities, you could write a program on the Pi that would realize power went out. It would realize when the UPS died, could see power come back, give it time to stabilize, and then punch the UPS to turn it on. So there's a hardware problem that sounds like you got a lot of it solved. You have a large UPS with a small load that stays up for a while. You've got something that can think. And so what you need is a kick the button and a way to know if you have commercial mains and a way to know if your main UPS, or go ahead and look at both UPSs, are putting out power or not.
Okay. Yeah. So I have a lot of those remote outlets, switchable outlets, right? That I could plug onto the UPS, um, and by seeing if they're online, I would know whether that there was power coming out of the UPS, and it could be there are battery protected ones and non-protected ones, and so if you had one on
At my
each.
house, I've got a lot of CTs around because I wanted to also measure the current on a couple of different circuits and stuff. But at a minimum, it tells you if that particular circuit's on or not. And you can also have a CT on the output of the UPS to see if it's providing current.
Right.
So this is this was a circuit board that is an opto isolator I did for a similar project. I want to know if I have AC power, and if I could figure out how to flop the video in this thing, you'd make more sense reading it. World's simplest board, opto in, opto out with fusing TVSs, and you get this pull to ground that can sink a couple milliamps, more than enough to optically isolate your power, draw very little power. I mean, I'm putting about 6 milliamps through the LEDs. It's one of the optos that has the two diodes back to back, and you get the base out on the collector, so you can put a cap on there so it goes ahead and filters it. You don't get a 60 cycle burst out of it. You get a constant, I'm pulling to ground because I'm seeing AC. So there's your how to sense things. Let me see if there's any way I can get the video to be happier.
It's actually correct for us.
Yeah, we see it fine. Yours is switched because they mirror your input, so it looks like you're looking in a mirror.
Okay. So I'm seeing it right now. Are you seeing it reversed?
No, we're seeing it correct.
Oh, okay. Then we're all happy. So yeah, so very, very simple little board.
And what is the DC output level? Is that 5
So
volts?
basically the opto is open collector, NPN open collector. And what you're seeing, you see the green block here,
Yeah,
and those are two little resistors, and that feeds the AC in. And then the output comes. There's a 140 milliamp fuse on it and a TVS, and it'll pull 2 or 3 milliamps, no problem. Probably pull about 10 mils without any problem. The key thing is the opto is one of the ones that has the back-to-back IR LEDs on it, and the base comes out so that it effectively filters the AC. So even though you've got AC coming in, you'll get a constant pull to ground if you have AC. So if you're not worried about voltage or anything else, two of these guys, and you can know I have commercial mains, and I have my main UPS is up and running, and then output. And I'd go with a relay just because who knows what the switch on the UPS is floating on. Is it as clean as an input to a micro, or is it something where it's going to temporarily shoot juice to a micro, and the micro will then keep itself on when you release the button? You don't know what you have. You can't go wrong with a relay. And then you just reduced everything to a simple matter of programming.
yeah, simple matter of programming. So does that say 18 volts on the output?
That's the opto I put on there. I
Oh,
think
okay.
the part can go up to 30 or something. I was using it. I take that, and this runs off a car battery, and then it goes into a car battery circuit and goes with other things to turn on a microprocessor. But I wanted to make a general purpose board explicitly for AC, right? All the right clearances, a nice way to, those are, I think, 33K resistors on there, so it's not much power.
Yeah.
But the key thing is, there are two things you need to sense and one thing you need to kick. And that would let you do a lot of stuff. Food for thought.
Yep.
For reference, I have a Raspberry Pi running on a Ryobi battery, and it draws about a quarter of an amp.
Yeah, I've got a. So those battery. There.
And you don't have to use a full Pi. You can use something like as simple as an MPS or any of the old Arduino chips or something. This Saturday I'm going to be going over with the beginning club on using the Pi Pico.
It's a battery protector for a vehicle so that you can leave things on. In this case, it was some communications devices. And when the battery gets too low, it'll shut them off. It deals with all the hysteresis stuff and also has temperature sense on it. Relevant to this conversation is that little chip in there is like $4. It's got 32K of flash. You program it in C. And so if you really wanted something that was going to sit and draw less than a watt of power and do the control, and you enjoy embedded programming in C, that's an option. I think like a lot of problems, the best option is the one you have the skill set for, not a particular part, operating system, or circuit board.
Right.
Is that an SD microchip or is that an NRF chip from Nordic?
The processor is a TMS 430 part from TI. It's a 16-bit M0 ARM. And there's all the usual. This is why the pandemic was fun. Is everything has a learning curve. So after a few months of saying nasty things about TI, I finally got the hang of it. Got all the subroutines done, the part for the serial port and the I2C and all that. And then all of a sudden, it's easy to do hacks again. But somebody mentioned a smaller processor, not a Pi, that would draw less power, and this would be an option. That thing, when it's running, goes to sleep, and every 10 milliseconds it wakes up. So the average current into the micro is 4 milliamps at 3 volts. So it can really sip power.
All right. Any other ideas?
I'm not sure about how to start up the UPS again, but I'm familiar with just the reverse, where you have a web-based relay. It has its own web server on it. You log into it, and some of them are like they look like power outlet strips. And through the web interface, you can turn relays off and on. So, I mean, that's a way to turn things off and then turn it back on, switching AC over the internet with a web-based relay. But I'm not quite sure what would be needed to, when power comes up, then um, make your UPS button push. Maybe there's an alternate input to the UPS that would accept that signal.
Yeah. And perhaps if there are ways to have your computer shut down before the UPS totally dies. And so if you did that when the battery was, at 20% or something and shut the computer down, the remaining power in the battery might last through a much longer power outage, and I might not need to poke the button.
I think they need to figure out if you want to have access to it over the net while it's happy, or is this something that's going to run standalone without your being there? Have a huge impact on the route you take.
Right.
Right, the little micro, yeah, it doesn't draw much power. Boy, who likes to do anything with networking and C? The Pi, okay, yeah, you're going to lose, 3 or 4 watts, but now you can network, pick the programming language of your choice. You clearly can have remote access, etc. And
I mean,
I don't
if I'm
know.
at home, I can go press the button myself. So this would be when I would, when I'm out of the house for some reason, instead of having to call a buddy to go over and break into my house and push buttons for me.
If I don't know if the some of the UPSs have serial ports or serial via USB. It sounds like part of this also is you'd like to be able to have a estimate of how soon is it till the UPS dies, so you could do a controlled failure or controlled dropout.
Yep.
I can show you an overkill approach.
Why not?
Plus, it's another fun pandemic project. Let's see here. Come up a little on this. And let's get it the right way up. So this was a really fun board I did during the pandemic for a mobile server. It's a dual 50-watt power supply, boost buck. The idea being it's running a server in a vehicle. So it can get as low as 6.5 volts, as much as 18.5 in. And the 2 power supplies. This works because there are a lot of little boards like 8-core atoms that draw about 40 watts. And they're 12-volt only supplies, not the big ATX connector. And that serial port on there is so you can configure it, but there's another jack right here. That's the second serial port. And that port every 4 seconds dumps a JSON object telling you the battery voltage, all the output voltage, the input, the currents on everything, battery current in, both power supply currents, and temperature. And that would let you monitor, you put this on a car battery, put the car battery on a 13.5-volt wall wart to keep it trickled. And then you can sit and look at the car battery voltage and say, well, this is getting kind of low. And then it also has on it a single pull to ground output, which is this little LEDs on it here. So that would be a way to have something where you would have a device that was running like your Pi on its own little UPS, the car battery, and you could know the voltage of the battery, and you could also see how much power it was drawing. And actually, there are 4 more little output pins right here you could get on. And you could use those as sensors for AC if you wanted. It's overkill, but hey, overkill can be fun. But the key thing is, I think that the point here is less about this board than it is a solution for being able to determine how much time you have till the batteries that are giving you power are unhappy.
So this is like building your own UPS, right?
It is, because this had to be in a vehicle, and I want it to turn on when the vehicle turns on. I want it to run after the vehicle has been turned off, but I don't want it to drain the battery.
Right.
And I want to have the serial port giving the Unix operating system telemetry about what's going on.
Yeah.
And it also has another output on it way down in this corner that goes to the button on the server, so that when it knows it wants to take the system down, it can push the button, and then the server will start running the shutdown process. So it'll save all your data and do a good shutdown.
Before you before you pull the power. Yep.
Yeah, yeah. And the serial port lets you pick thresholds for the when the voltage is too low, how long after the voltage gets low before you shut off. So on the serial port, it will tell you how long you have till shutdown. So in Unix land, the task looking at the serial port would say, well, we're going to go down in 5 minutes. Let me get a warning out to all the users and then shut everything down. So there's your overkill. Might be easier to find a way to just measure the battery voltage on the device, even if it's some fixed system that takes that in an opto and draws a little bit of current. And when it gets battery voltage gets low enough, the opto will draw out, and you just calibrate it with a pot for that one case. And now you've got something that says battery is low as one of your inputs. So you have commercial mains on, output on, and battery is okay or low. And then your output would be a relay to kick the button. And now you're back to a reasonable solution.
A lot of PMIC chips already have quite a bit of that functionality built into it, and you can calibrate to that particular battery in terms of percentage low, how much time you got, things like that. And most of these PMIC chips are about $1, $1.50.
So did you spin that board? You said you did that board. Was it a volume run, or you did it just
I ran 25 of them.
for yourself?
For the fire departments that I'm designing
Okay.
systems for myself. Plus, it just seemed too useful, right? How many times how nice is it to just take an old car battery or a tractor battery, make power, and the two outputs, so you can have one at +5, one at +12. I just couldn't find anything I liked commercially that had it, particularly the microprocessor and all the smarts to give you warning. And yeah, like I say, it was a fun challenge too. It was a brand new chip from TI. Yeah, the I2C C-bus lets you set all the timing for how long you can take an overcurrent before you get unhappy, setting all the voltages, setting current limits. So unlike a supply where you'd be soldering resistors here, you can just get on the terminal on the serial port, and there's a little program in the micro that lets you talk and set all that stuff. So fun project. But yeah, I haven't looked at the power supplies today to see what they have, but I sure hope they get to a point, if they haven't already, where they can give you all these kinds of warnings.
A lot of the PMIC chips that are out are dedicated for, well, not dedicated, but geared toward the IoT universe and cell phones, that kind of thing. So that's why the PMICs have gotten a lot more capability now and gotten a lot cheaper. I just worked with one this last summer, and it was a pretty darn good chip for what they were trying to do.
Okay, very good. Any last comments on the problem of the month? All right. Well, let's open it up for show and tell. Peter's already shown a bunch of stuff, but we can always see more.
As part of my journey into low-cost Chinese micros, I got this little board, which is $8. It has an Ethernet port, 4 USB connectors, A to D converters, D to A converters. For $8, I couldn't not buy it. I'm a sucker for things like that, and it's part of the. It's the same. It's a RISC-V, same as the tiny boards that I have. I don't have any particular use for it. I plugged it in, made it wiggle, and said, "Oh, that was fun." Um, and that was my $8. I could have bought a beer for it, but I wouldn't have had anything to show.
Okay. So I promised an update on the CAN bus stuff that I was looking at from last month's problem of the month. So I purchased a connector from Amazon. It's got 16 pins, 16 wires. The CAN bus runs on 3 of them. Another one is chassis ground. Another one is the battery power, 12-ish volts. And I don't know what the others are. I haven't tried probing to see if there's anything on any of the other ones. And then, so you can't just hook up the 2 wires from the CAN bus to your micro. I guess maybe you could, but you'd have to do a lot more work, analog reading them and stuff. So I bought 3 of these little interface boards from Amazon. Has 2 chips on it. One is a transceiver that hooks up to the 2 wires of the CAN bus, and the other one is a controller board that knows how to capture CAN packets and do things. So this is the controller chip. It implements the CAN bus. It can do transmitting and receiving. It can filter packets so that you can tell it which packets you want to be looked at and which ones it should just dump. It has an SPI interface. And this is the transceiver that converts the differential values on the CAN bus lines to a digital signal that you can feed into the controller. So CAN bus, the wires sit at about 2.5 volts, and it will pull one of them high, the other one low by about a volt to get a logical, I guess it says low. Yeah. The low value for the bits is there, and when they're kind of floating together, that's a high. So one of the first things I did is I hooked up a scope to those 2 wires to see what they looked like, and this is what it kind of looks like. I'm assuming that each one of these little wiggly things is a message that's being sent over the bus. I zoomed in and kind of measured the time between the peaks and valleys, and it comes out to around 500 kilohertz, which is what Google told me that Toyotas use. I'm sure that's the default value in the spec. The controller has a message assembly buffer that collects the message as it comes in off the wires. And once it has the message totally received, it sticks it into one of the other two buffers, receive buffers. If the filtering criteria is met, and then there are some error counters in case you receive, in case it detects errors, two people trying to talk at once, other reasons. So far, I've seen a lot of errors, a lot of message receive errors, and I've never gotten a message captured in the buffer. I've only tried one of the three interface boards that I got, so if I had brought another one on vacation, I would have been able to swap it out and see if that made any difference. If I had my soldering iron, I solder a little wire onto the signal between the transceiver and the controller, and try to look at what the digital signal looks like between the two chips. And so it's been kind of frustrating. It took, I plugged it in and nothing worked. The examples, right? And so I started, reading some registers just to see if I'm actually talking to the controller, which I was. And so I started dumping the registers, and I saw that the receive error counter register was counting up to 128 where it gets clamped, and it was setting a bit saying that there was an error interrupt pending, and um, so lots of errors, no success, and I don't know why yet, but I'll probably have it figured out by the next meeting.
Is the CAN bus floating at 2.5 volts and the signals pull differentially away from that?
That's correct.
And so it's a DC coupled bus, no transformers.
Yep.
Okay.
So I have a question. I may have missed what you said, Paul, about um, how you're connected, what you're connected to. I posted something there from Copper Hill Tech, which I'm also working in the CAN bus area. And on that copperhilltech.com, um, I've had great success with um, their Raspberry Pi based cards. That's just one that they're less expensive ones. This one has its own built-in power supply, so it can supply power to the Pi. It also has a battery for real-time clock, but it has a DB9 connector as well as the screw terminals for the CAN bus high-low power and 12 volts. Um, and anyhow, they've worked out great for me. And I've loaded the Python um, Python CAN um, library onto the Raspberry Pi, and it's all free. It's in Python, and anyhow, it gives you the logging tools. There's a lot with that Python CAN library, but you can open up Windows, terminal windows, and you can see the CAN bus activity. And yes, 500K is pretty much the standard. They're automotive. It's the high speed stuff. The engine and drivetrain run on 500K, and the other less sensitive things run at 250K. But anyhow, just any of the boards from Copperhill Tech that go on the Raspberry Pi work with that Python CAN library, and it just works. It's very easy. Um, I did a whole project. It's CAN bus, and I use their CAN card. I have a dual CAN bus with the 5-volt switcher on it. And then I made my own hat to stack on top of that so that I could trigger an arbitrary waveform generator externally to supply a time of flight type signal. So I delay my response um, with the external trigger, but it's all my work is CAN bus. At this moment, I'm working with a CAN bus sensor. So Copperhill.tech is where I would go for CAN bus um, development stuff. It's all open source too. You can see the schematics that they have for their boards, and all the Python libraries work.
If
You know,
you
from
don't
from what I
mind
saw
the
on the internet, this is all supposed to work, right? I mean, most of the examples, if you Google and Arduino and CAN bus, you'll get one of these interface boards, and there are a couple of different Arduino libraries for doing it. You know, there's examples. It's supposed to spit out every packet it sees. I haven't figured out what's not working yet.
if you don't mind the not quite as easy and not Arduino, this Chinese card has two CAN bus interfaces built into it for the $8.
Yeah, the,
Um,
the ESP32s have a CAN bus controller built in.
yeah,
You still need the transceiver chip.
yeah, you need a transceiver. You need a transceiver with that too.
Yeah.
Could be something stupid simple as loading on the line.
I guess it could be just about anything, right? There's a so normally the CAN bus has a 120 ohm termination between the two wires at each end of the bus. There is a jumper on this board to put the 120 ohms across them. I haven't tried that to see if that makes any difference. You know,
I was just wondering if you were getting too many reflections or anything. If you thought about putting the CAN bus signal on a
yeah,
raw analog signal.
yeah. I don't know if the little OBD scan tools that you plug in to your OBD port have the 120 ohm on them or not. I guess that's something I could try.
From what I've seen, they don't. It's just a connector. It goes from one form factor to either all those conductors, or they terminate to the DB connector. And there's two different wiring. If you look into that board that I I posted, they give you the two possible termination. So you either have to wire your DB connector to their board, or use uh, pick the proper signals off of the ends. I bought one, but I never got to that part yet. Mine's just straightforward, and I know what my signals are on the CAN bus, and I have my terminator resistors installed too. They're not needed at intermediate points, but they are supposed to be installed on the endpoints.
So that transceiver chip is showing a input impedance on each pin of 25K. So I think you could rule out that the transceiver chip is loading things down too much.
It does have. Oh no, that's the controller chip has a listen only mode. I tried turning that on, and the behavior changed, um, not necessarily for the better, but so I don't know if it's possible that the receive errors that I'm seeing are actually self-generated by the controller. The controllers normally, when they detect an error, they spit out an error message packet on the bus to let other people know that they've encountered an error, and they can compare what they send out with what they get back, and if they don't match, they generate errors. So there's a list of different possible errors or reasons for having errors. There isn't. I haven't found anything has like a bit vector that tells you which errors have been detected and which haven't. So I don't. Yeah, I don't know what's going on yet. I was a little hesitant to plug this thing into my car while I'm not at home. It'd be really bad if I somehow burned something out in my car and couldn't drive back to Raleigh.
You had the picture up of the scope showing the two differential lines. It'd be interesting to see that and then look at the actual digital output from the 1050 chip.
Yeah, that was one of the things I was going to try to do, but I don't have all that stuff with me at the beach here. All right, other show and tell?
Okay, if I share my screen,
Absolutely.
I've never done this, so hope it doesn't explode. Can you see it?
Yep.
Can you see this?
Yep. Whole bunch of little numbers.
Yeah,
There you
that's
go. That's what you want.
the Maria database that's capturing my hot water heater on-off times on each row and calculating the elapsed time that it's has been on. And if you look on the left, the first two's there were tests. I was just manually simulating on offs and just to. I've been doing this quite a while to just hacking through and getting my database as good as it is now. It's still not exactly the way I want it, but this is it right now. Okay, and the next one, uh, one. Let's see if I can find that. Yeah, this is my newer database. It's my energy, and the I've been running this Pi on my hot water heater uh, probably over 10 years. That Pi 2 with a Wi-Fi adapter, and it's still chugging. Anyway, I'll go to the next one here.
And how are you sensing whether it's on or off? Do you have a?
Hold on one second. I'll get to it.
Okay.
Uh, let's see. This here is the
All
H.
this is too small for us to read.
Oh, sorry. I wonder, can I expand this up? Can you see it now?
If I were at home, I might, but
It's anyway, it's H top, and it's just showing the
okay.
Python program that's running and eating up 100% of one of the processors on the Pi.
Yeah.
Okay, and the next one is I'll come back to that. That's a thermostat. I'll skip through that. Okay, this is my manual simulator buttons that I did to uh, manually cut on and off a signal to the Pi to simulate the hot water heater on and off or HVAC or whatever. And it's not funny, but I burned up a Pi 3 trying to do this with a switch. I wired it wrong, and I figured this is much easier than trying to do a switch, and you get a quick feedback. It's on or off. Okay, this is a Pi Zero I'm using for a remote temperature capture, and I can call it up on by the IP address and anywhere in the house. And I'm going to try to make this a weather station and do not just temperature, but all the wind speed and those kind of things. Okay, here you were just asking about the water heater. It's a uh, AC to DC rectifier little thing. I got a hold of a design off the web, and I uh, went out to Osh Park and had a little board made. And of course, you can see it. I flip back to like this corrected set point. All that is right now is the square root of two, I think, and it just adds it to just for a placeholder. To, if you wanted to get real, if you had like say AI or something that you knew a bunch of conditions that were going on to affect a given device, you could put in based on some equations or equations what corrective type things you wanted to adjust your settings to maintain or minimize your energy usage. So this is kind of the whole thing. I know it's not that exciting and sexy, but like I say, it was interesting to me, and appreciate you letting me share it with you.
That's how the world of smart homes got started. Exactly what you're doing.
Really?
Yep, they first started trying to save some energy with their thermostats, and then they added on things like, can I get a signal in from my smoke detectors and my carbon monoxide detectors? Oh, and then can I add a security camera? It just grows and grows. But it all started with playing around with a thermostat and seeing how you modify how you program it and stuff.
I did
One
not
of the
know
first
that.
things people, yeah, one of the first things people try to do from here is auto detect should I be in heat or cooling mode based on another probe outside to see what the outside temperature is.
That's exactly kind of what I had in mind with that zero pi zero is sticking it outside and collecting enough data uh, to where you'd say if this condition exists, and you can predict the next, and maybe you can get the weather station to help you out a little bit. And you know you need to bump up your thermostat or bump it down or whatever to and so it won't overshoot. And sometimes you do that, your house gets too hot, and then you go too far the other way and back and forth. But if you had a really smart device, I don't think Google's Nest. I don't know how it works really. I think it's mostly on it. It tracks the human setting on it.
There's also another bit of thought here is if you're gone from the house for quite a number of hours, you can change your set points to make it more energy efficient. And then what you want to do is you want to calculate the recovery period. Now, if you're in a heating mode, how long does it take to go from ambient temperature to desired set point? And you can calculate that as a graph or an angle. And then if you're in cool mode, how long does it take to cool it down from ambient to the set point? And what you can do is predict so that when it knows that you're coming home, say you come back home to your house at 5:30 or 6, it can predict how long, based on that curve, the math equation
Yeah,
of how long should you run your unit to have a comfortable temperature when you walk in the door. So you
yeah,
can go from energy save to comfort mode.
absolutely. I think a lot of people when they come home and it's freezing in the house, they turn on that heat, and the first thing that pops on is that resistance heater in the unit instead of the heat pump, and it drives up the electric cost. And I think
That's exactly why people are doing the trying to do the predictive curves, trying to save that secondary heat source.
yeah, you know, I'm not even I don't know what as far as learning predictive type stuff. I guess I believe with Python, you got some options to go in and start studying and learning some of it. And of course, I don't know if I'll live long
I'm
enough.
not. I'm not even talking AI. All I'm saying is you could calculate the slope, the amount of time it takes to go from one point to the other, and then predict. Okay, now my comfort set point is this much higher. I'm going to want to go to that. How long is it going to take me using the standard, primary heat source as opposed to secondary heat source to get there, and then change the set point that far ahead of time so that you never run the secondary heat source, and it'll be a comfort temperature when you reach the house.
Yeah, so you never have to.
So it's just a matter of a math equation. It's not really AI. It's not really predictive analysis. You're just calculating the slope, the time versus temperature change,
Is it?
and how long do I need to extend that for a change in the set point?
Are you saying maybe like using least squares and something like that?
Not even that fancy. Just a
Okay.
simple. How long does it take to go from when the unit kicks on to when the unit kicks off? How long does it take to do that? And then the set point when it's kicking off because there's a slight hysteresis. It kicks off at say 2 degrees above the set point.
Yeah.
Now you want to know what your new set point is going to be. Because say, for instance, you're away from the house during the day and you wanted a change or a different, what I call a comfort set point. How long will it take to go from the point where it kicks the furnace on to reach that set point? And say it might take 15 minutes longer. Well, then you change your set point 15 minutes early so that it's at comfort level, but it's gone the slow slope, not the slope that's going to use the secondary
Yeah.
heat source.
Just creep it up
So
a
in other
little
words,
bit
you
at
can
a
change
time.
your set points 1 degree at a time so you don't cause the secondary heat source to kick in.
Yeah, I think I could actually program something like that myself. Uh, that doesn't sound too hard, really.
One part to look at, especially if you're messing around with AC voltages, is AMVECO, AMVECO, makes a whole range of AC current transformers. And they're, as current transformers go, it's a high impedance, which means if you open up the secondary, it doesn't get upset. And you take that and you throw a resistor across it, and now you have a AC voltage proportional to the current.
Tell me
And
that again. Let me write it down.
oh yeah, the Avemco, AMVECO,
That's
and
it. V is in Victor.
yeah, uh, Alpha Mike Victor Echo Charlie Oscar.
Okay, got it.
And then go to Mauser and just look up the part number AC 1020, Alpha Charlie 1020. It's a 20 amp current transformer. Then you take that, and there are true RMS to voltage chips out there. And after you put the little resistor on the current transformer to set what your output voltage range is, you go into that, and now you have a DC voltage linearly proportional to the current. So you can not only tell if it's on, but you can get the current. And the other thing I really like about it is you're not messing around with any high voltage going anywhere. Uh, in my breaker boxes, I have these on a number of circuits so that I can basically see what's going on. So if you're messing with AC voltages and you go to a little extra work, you can actually get a proportional voltage to the current being drawn and tell not only is it on, but how much is it drawing. If it's a control system, what's the standby current? What's the current when it turns things on? So the current transformers are fun. They give you a good range of voltage, and it's a lot safer when you're messing with AC power.
That's for sure. Yeah, I was really careful
I
with
was talking.
that. Who am I talking to? Who's talking?
I'm sorry. That was Peter that was just talking. This is Scott. When I was talking about CTs earlier for Paul's problem, that's what I meant with current transformer. You can put a current transformer on the AC line and put a current transformer on the output of his UPS, and you can detect when the current is on or off on each one by checking that proportional DC voltage, because you're looking at the DC voltage across a resistor of the output of the current transformer. So when I used the word CT earlier, that's what I meant with current transformer.
Okay. Yeah, that's good. Good to know. I just, it was like grasping things. I knew a one wire through a little clamp on transformer would probably work. And I just bought what I thought might work and tried it, just, so happened it worked. But it was hard. I had to do a lot of work to figure out the 18 volts it was putting out AC, and get it to where it was a usable a value for the Raspberry Pi. But this sounds like really, I had no idea they had these things, so that was really helpful.
Yeah, and opto, if you just want to know if you got power or not, and a current transformer, and an A to D converter, and now you know the exact amount of current, and you're good to
That
go.
is so cool. Yeah.
Pick which one you need based on what you're doing.
Who's a good vendor for those things?
I buy Bowser and DigiKey are good sources for all of
Okay.
them.
Yeah, I bought a lot of stuff in DigiKey.
Yeah, DigiKey has got also a lot of the engineering charts for picking the right one. Newark Electronics is also another good source.
What's that? No, I'm sorry. What was the other
Newark,
one?
NEWERK, or is it ARK? I forget which. I think it's ARK. So NEWARK.
NEWARK. Oh yeah, Newark.
Yeah.
Okay. Yeah.
Yeah, they're the ones that picked up the old Graham Electronics and a lot of the other electronics warehouses in the country. I
Okay.
used to work as a kid at the one out of Fort Wayne that was as big as the one in Indy, and they got bought up and became Newark.
Yeah, I bought a few
And
things in New York.
I think
Nothing much.
Newark is Arrow now, right? Bought up by Arrow.
You know, I thought Newark and Element 14 were merged.
Oh, yeah, maybe that's
Yeah,
right.
I think that's right.
I think that's correct.
It's still Newark, Newark.com.
Still New York.
Okay, other show and tell.
If you can tolerate it, I can give you 20 seconds of circuit board porn on another board I did during the pandemic. Let's see. There we go. This was a nice, challenging RF project. It's a 1090 megahertz low noise preamp and a power supply so you can feed it power off the center line of the coax. And I got it off to the side there because the light on my little camera thing. Can you see the whole board, or do I need to move it?
Yeah, we can see it.
We see it.
Anyway, so the top part there is a boost buck, so you can feed it from 2.5 to 18 volts, and the bottom part is the LNA. And the dime is there for reference. This is a really challenging hand solder, and the core chip is a RF micro devices mimic, and the thing just worked really well. So there's your board porn. Everything else is RF geeky stuff. Fodder for another day.
So what were you saying? You supply it power through the coax?
Yeah. Basically, there's a 330 microhenry inductor, and then that goes off and feeds the boost buck. So the two challenges were obviously all the RF stuff, but also having a boost buck power supply on the same circuit board with a 1090 megahertz receiver system.
So what were you amplifying? Is that you were amplifying?
So 1090 is where the ADS-B traffic is from aircraft, where they broadcast their location and speed and altitude and all that good stuff. And so I wanted something where you could put a circuit board out really close to the antenna and just run in on any old piece of feed line and not worry about the loss.
I got you. And because it's an antenna wire, that's why there's power on that coax?
Yeah. Before you go into whatever the receiver is, in this case, it was a FlightAware USB dongle. You put a DC power injector that just, breaks the center conductor with a cap and then shoots some voltage on there. There's a bunch of stuff out there, but it's all a single FET. There's no voltage regulation, and the specs on it were terrible. That could be another evening in itself, ADSB, which is really fun stuff, tracking aircraft.
How far are you from the airport? I'm at the 5-mile marker on the north side.
I'm out here in Efland in Orange County, and actually the antenna's inside, but I still get about 100-mile range with it. This is more first responder stuff when you're flying a drone, tracking it so you can get an alert if any helicopters are too low to the ground and coming at you.
Yeah, I can't fly any drones at my house. I got too many planes at between 500 and 1,000 feet flying over.
Yeah, I lucked out. I'm out in the boonies. Oh, I'm gonna make one more comment about fun in the pandemic. I got up to speed on 3D printing, and in particular using the program Fusion 360. And I cannot tell you how cool it is to design a circuit board with KiCad, pull out the step file, bang out the chassis, and just do stuff you could never do down in the basement with a drill press and milling machine. And no spacers, no nothing. It all just goes together. After you've spent your first 200 hours yelling at Confusion 360, it's pretty cool.
It's too bad that Autodesk is dropping support for it and everything.
Yeah, I don't know where that's going to go. Still getting used to my controls here. Here we go. So this is a single little opto for a hack project I did. And the significance here is this entire project, the opto, the circuit board, and the case was a 1 evening, 3.5-hour job. In other words, banging this out is about the same amount of time it would have taken to mess around with the breadboard. But, I now have 3 of them, right? And a lot of work to get there, learning the KiCad and learning the Fusion 360. But, oh my gosh, it's so sweet. Anyway, that's all I have to say on that.
Yeah, it looks nice.
I have a question on ADCs, in particular, how to read voltages that are in excess of the VDD. So, like if the ADC is running on 3.3 volts or 5 volts, how do you read voltages that are, say, 10, 50 volts or even higher? What is the proper circuit conditioning elements to bring it down into that 0 to VDD range? Has anybody done anything with that?
The simplest answer to that is a voltage divider, and a more complex solution to that would be an op-amp pre-filter circuit.
Yeah, that's what I sort of sensed. I just as late as today, before leaving work, I had a conversation with somebody, and they said that you might be tempted to go to the voltage divider, the simple resistor, but you have to be careful because if the impedance is mismatched, your ADC won't give you a true reading. So the answer is some kind of some kind of circuit conditioning that is sensitive to the impedance, and it's possible that maybe some of the ADCs have that built into them. I don't know. I'm just getting started, but I do know that I am going to be reading voltages higher than VDD. So
How
something
much
needs to
higher?
happen. In the range of 30 to 35 volts initially, and maybe someday as high as 100 volts.
You can. It depends upon the ADC you're using. A lot of them have sample and hold gates, and they end up being very, very glitchy on the inputs when they acquire the data. So you are best off using an op amp in, probably a follower with gain or something like that, where you have a high impedance on the input. That's probably the safest thing to do. Um, if you get if you're doing much higher voltage, you can run it through a transistor. You run down into the base of a transistor, and then use that to do the level translation. I've run things up as high as 400 or 500 volts for Geiger counters, and you just have to be careful.
Yeah, it's a ways off for me, more in the late January, February timeframe, but that's the only thing that I am not familiar with, and I know I've got to get up to speed on that part of it. So
So I did
thanks
a
for that.
I did a system that was measuring 15 volts. It was actually a home automation. All my analog and digital inputs were all analog, and I did a resistor divider. Then I put a TVS on it, right, a protection diode. Then came out through about 2.2K. And since it was a sampling A to D, I put about I think a 0.1 mic cap on there. And what I want to do is because I was sampling at very low rates, the voltage divider makes the voltage, it charges the cap, and then when the A to D turns on, it sees a very low source impedance because the cap for that brief amount of time can pop the current for the 2 or 3 microseconds that the sampling A to D needs to get current. And doing that, I was able to do 12-bit A to Ds at the whole thing ran at about a 1 kilohertz rate fairly successfully. I think I agree fully with if you go right from the voltage divider into the A to D, you're going to have trouble because the apparent impedance of the signal you're measuring will be very high because of the voltage divider. But that combination of divider, TVS in case you get spikes, and then a resistor, and then a cap, and then you go into the A to D, gets that equivalent impedance of your source way down so that the sampling A to D will get a good sample. Hope that makes sense.
That's gonna kill the bandwidth on your signal, though. You'll get a good signal, but you won't have in a reasonably fast moving signal. You won't have much bandwidth.
You're very right. It worked for me because I was going at a kilohertz. If you want to go, I think even as high as 10 kilohertz, it probably wouldn't work very well, and certainly 100, no way.
Yeah, it's buffer amps are are cheap and easy enough, and that way, back to back diodes, so you can clamp the signal to a virtual ground. You can get away. You'll be fine. It's going into the base of a transistor, if you're dealing with very high voltages, is a useful way of doing it, but that gets a little more futzy.
No, your 500 volt solution sounded great. I'd never thought of that.
Yeah, it's also ultra low current because the Geiger counter is battery operated, so I can draw very, very low currents and not drain the battery. It's a if I spent more than a substantial amount of my life designing A to D converters. If you have any particular questions, I'm happy to help. It's a I know more about it than I care to.
But appreciate that. Thanks very much. And I also wanted to say I added a couple links to the chat. One is a USB CAN dongle. The dongle is not cheap, but the user interface software for it is free. And so that will allow you to have a PC based debugging tool. And also, I put a link to the Python can read the docs. There's a lot to understand there, or a lot of benefit there with Python and the Raspberry Pi and one of those uh, Pi base hats. But again, appreciate the info on the ADC. I'm definitely headed in that direction very soon. Thanks again, guys.
All right. Anything else anybody wants to show or talk about?
I'll give some more data, but the Edger project is actually now running on a Raspberry Pi in addition to the ESP stuff. It'll run on a number of other platforms, which I'm currently using for stuff. But I'll fill people in when I've got it a little running stably, which is entirely different from running.
Right. All right. Well, everybody have a great holidays and keep an eye out for info about for our January meeting.